how you doing? It's MrDoTheMath here, and today we're going to talk about special right triangles, right? This is going to be really, really quick, so I'm going to get straight to the point. Special right triangles, you got two of them, all right? The first one derives from equilateral, equal angular triangles, right? When you draw this altitude here, you create right triangles, right? Equilateral triangle, that means all of these angles are 60 degrees, right? When it's cut in half, that's 30 and that's 60. So we're talking about the 30, 60, 90 degree triangle. Okay? With a 30, 60, 90 degree triangle, it is clear that the legs are going to be different lengths, right? And so they all have a name. So the smaller leg, which is actually the side cut in half, is the short leg. Then the altitude is known as the long leg. And then this side is the what? Hypotenuse. All right, now each portion of this triangle has its own separate identity or its own separate relationship to each side. They are related in a specific way. All right, short leg is the base of all the other components, right? So if the short leg is x, the hypotenuse is going to be double x, right? It's 2x. Right? And then the long leg is always the short leg times the square root of 3. Okay? That's it. So, the side where 60 degrees is always the short leg. So if I said the short leg was 3, the side with the 30 degree angle is going to be 3 times the square root of 3. And the hypotenuse is always going to be 2x. 3 times 2, which is 6. Right, let's look at another. Bop, 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 bop. This is 60, this is 30. What if I said this is 28? All right, that's the double side. Half of 28 is what? 14, short. And then 14 root 3 is the long leg, okay? So again, short leg is the x identity. The hypotenuse is 2 times x, 2 times the short leg. The long leg is the short leg times the square root of 3, okay? Now, there's a situation when you get an actual number. You get an actual number for the long leg, like a whole number for the long leg. And so when you think about this, if I simplify it, you watch the videos to like go deeper. But if I simplify this, if the long leg is a whole number, then the short leg is going to be that whole number times the square root of 3 over 3, right? So if this is an actual number, then this value is going to be that number times the square root of 3 over 3. Okay? In our other video, I'll break it down. All right? So then if this is the square root of 3 over 3, like you could technically reduce this. This would be what? 12 over 3?
Yeah. 4 over 1.
4, right? 4 root 3. All right? So this is 4 root 3. So if this is 4 root 3, what's this length?
4.
No, 2 times 4 root 3. 8. Yeah, 8 root 3. Okay? Does everybody need to see the math for this, though? How did I get 12 root 3 over 3? Do you need to see that?
Mm-hmm.
Yes? All right, so this is 12. The long leg is 12. The long leg is also known as x root 3. Right? X root 3. So if I'm solving for x to figure out what this is, I would divide both sides by the square root of 3. Right? So now I have x equals 12 over the square root of 3. You can't have a radical in the denominator, so you got to multiply the top and the bottom by that denominator. Right? So then you end up with 12 times the square root of 3 over the square root of 3 times the square root of 3, which is the square root of 9. What's the square root of 9? 3. So that's how you get 12 root 3 over 3. Okay? Let's do another example so you can see it again. All right, this is the 60 side. If I said, give me a number, we're going to use an even number, 20, right? Again, when you got this number, you just got to add root 3 over 3. So this would be 20 root 3 over 3. And this would be 2 times 20 root 3 over 3. Which would be what?
40 and 6 over 6.
No, just 40. 20 goes into 1. All of this is one number, so once you multiply this by 2, you got that. So it's 4 root 3 over 3, 20 root 3 over 3, and 20.
You don't multiply.
Oh, you don't gotta multiply like the other numbers.
No, you leave it like that. Right? You leave it like that. Alright, so that's your 30, 60, 90 triangle. Alright? Let's go to our next type of special triangle. Remember that root 3 over 3 stuff. Alright, so now this one derives from an isosceles right triangle. Isosceles means what?
Oh, so 2 out of 3 the same.
About 2 of the 3 sides are congruent, right? With the isosceles right triangle, you have a 45-degree angle, right? So the relationship of the legs and the hypotenuse of an isosceles right triangle are a 45, 45, 90-degree special triangle is these sides are x, they're the same, and the hypotenuse is the side times the square root of 2. All right, plain simple as that. So just like you do now, when I said that if this is isosceles, I said this is 12, then this side is 12 because it's x, they're the same, and then this side is 12 root 2, not 32. Good?
Yeah.
All right, one more. Pop, 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 pop. If I said this was 5 root 2, what's this?
5.
What's that? Yeah, easy, right? Easy peasy. 5 and 5. What if, though, what if this becomes a number? Like, make it, let's make it 20 first, it's an even number, right? If this is 20, then this is going to be 20 root 2 over 2.
How'd you choose 2?
How did I choose 2? Because the relationship of this hypotenuse side is x root 2, right? And so if I'm solving for x, which is what these values are, both of these sides are x, then I'm dividing by root 2 to get x by itself, and then I got to get the radical out of the denominator. So I have to multiply the top and the bottom by square root of 2, which leaves me with 20 root 2 over 2, right? Because the square root of 2 times square root of 2 is 4. We good?
Yeah.
So that's root 2. And then it simplifies, of course, right? Which is what? What is this? 20 root 2 over 2 is what?
10.
Oui. 10 root 2. In German, how you say it?
Zen.
Zen root 2. Zing, zing, zing. Alright,
Yeah.
in Spanish, 10.
Yeah.
In French, 10.
Yeah.
Oh.
10. Alright, what if I give it to you, I give you this one. Alright, if this is 15, if the hypotenuse is 15, what's the measure of these sides?
15 over 2 over 2.
Very good.
And that's the answer?
That's it. Special right triangle.
Oh, good work.
Yeah. This is a quicker way, or a shortcut way to find the lengths of triangles, special right triangles. So right triangles that are either isosceles or 30, 60, 90, right? And we can check all of this out by using our main formula, which is Pythagorean theorem, right? We'll get the same answer if we do it that way too, okay? But that's pretty much it, special right triangles. All right, you got your isosceles, and then you got your 30, 60, 90 that came from an equilateral triangle. Anybody, any questions?
So when did you root 2 and when did you root 3?
When do you root 2 and when do you root 3? All right, which one? So this one gets the root 3,
Yeah, nice.
and this one gets the root 2, right? That goes to the hypotenuse, this goes to the long leg, okay? So remember that.
Which one is wrong with it?
Which one is the long leg? It's the altitude. The altitude is the long leg. And SL is the short leg. SL is what my grandma used to call my grandfather. Because his name is Sir Lee. Alright? So, if you got any more questions, comment below. Don't forget to like and subscribe. MrDoTheMath out.